Hey, let's break down the non-inverting operational amplifier in just 60 seconds. Here's the deal. In a non-inverting op-amp, your input signal goes straight to the plus terminal, or the non-inverting side. The result? The output stays in phase with your input. No flipping the signal around. What makes this circuit cool? First, you get a nice voltage gain, but your signal's direction doesn't change. Plus, the input impedance is super high, so the op-amp barely draws any current from your source. That means it's perfect for sensitive signals. Let's talk basics. Your input voltage connects to the plus terminal. There's a feedback resistor, RF, going from output to the minus terminal, and another resistor, R1, connecting the minus terminal to ground. Now, the magic formula for the voltage gain is 1 plus RF divided by R1. So, the higher your feedback resistor compared to the one going to ground, the more you boost your signal. Example time. Say, RF is 9 kilo ohms and R1 is 1 kilo ohm. Plug those in and your gain is 10. So, an input of just 0.2 volts gets amplified to 2 volts at the output. Super handy, right? You'll find non-inverting op-amps everywhere, amplifying sensor signals, acting as buffers, powering audio circuits, and more. And here's a bonus. If you set RF to 0 and R1 to infinity, you get a voltage follower, which just copies the input with no gain, perfect as a buffer. So next time you need clean in-phase signal amplification, think non-inverting op-amp. Simple, powerful, and everywhere in electronics.